Hey y'all. Before we start, I would like for you to go grab your graphing calculator. Okay. So go ahead and hit pause really quickly so you can have some time to dig out your graphing calculator. Okay. So today we're going to start with 2.6. It's called, the title of 2.6 is Mathematical Models and Building Functions. Okay. This is probably the most difficult section out of all sections in Chapter 2. So if you think it has been difficult for you, then you need to start attending tutorial because this is going to get very difficult really fast, okay? So let's start with example 1. Let P equals coordinates x comma y be a point on the graph of y equals x squared minus 1. A, express the distance, which is called d, from this random point here to the origin, which is at 0, 0, as a function of x, okay? So let's talk a couple of things. A function of x, as you have so far seen, this, okay? F of x is a function of x. So for example, I can give you x squared plus 2x plus 5, okay? So this is a function of x. Or g of x is also a function of x. G of x equals, let's say, 700x to the fifth. Okay, so both of these are called the function of x. Okay, so anytime that you are given a problem, the first thing you might want to do is to do a little sketch of this particular function right here. Now this is a parabola. Okay, so let me zoom in really quickly. This is a parabola with the vertex at 0, negative 1. Okay, so the first thing I'm going to do is I'm just going to sketch this out using a straight edge here. Okay, so vertex 0, negative 1. Here's positive 1, here's negative 1. So when x is 1, 1 squared is 1, 1 minus 1 is 0. And as a parabola goes, it's going to be symmetrical. We're just going to sketch out this point. This function. Okay. Okay. So it says, hey, there's a point, a random point, p comma x somewhere. I'm just going to pick this point. So let's call it p. P is x comma y, I meant. Okay. So p equals x comma y. Somewhere here. Express the distance d. So we're going to go this right here. This is distance d. Okay, distance d. From P to the origin, so P to the origin, as a function of x. Okay, so let's recall the distance formula. Distance equals big radical. If you remember in Algebra 1, it's x sub 1 minus x sub 2 square, add it to y sub 1 minus y sub 2, and we're going to square it. Okay, the reason we have to square it because it's a distance, it can't be negative. Okay, so if you have to agree with me, at the origin, the point is 0, 0. Okay, so this, if this is going to be 0, 0, both of the x1, y1 will be gone, or you can even choose x2, y2 to be 0, 0. Okay, so I'm going to go distance equals, so let's plug it in, x minus 0. Okay, so this is my x1, this is my x2. We're going to square it, plus my y1, which is y, y2 is 0. I'm going to square it. So as you can tell, that leaves me with simply x squared plus y squared. Okay. That equals you my distance, okay? So now this equals my distance formula. Now, if you think of it, I want the distance, according to the definition, as a function of x. Okay? That means I only want x and only x in my equation. Okay? Well, my distance right now has y. So I can't really keep it in my distance in terms of x. So I will need to get rid of y and put in x in it, okay? But as you remember, y is x squared minus 1. So I'm going to take out the y and put in, every time I see a y, I'm going to substitute it with x squared minus 1, because this y is that, okay? So x squared minus 1, and I'm going to square that. Oops, you can't really see that. Ooh, there, zoom out a little bit. Okay. So took out the y, substituted with x squared minus 1. Okay. So this is my new distance formula, okay, in terms of all x's. And I'm just going to go and simplify that out really quickly. So I'm going to FOIL out my x squared minus 1. So bring down my x squared. I'm going to FOIL out x squared minus 1. So right now I'm just going to, oops, minus 1, not plus 1, minus 1. I'm going to write it out twice. Okay. So I can FOIL it. So now my distance in terms of x, hopefully I have enough space here. Big radical, x squared is in the front. X squared times x squared is going to be x to the 4th. So it's going to be a plus x to the 4th. X squared times negative 1 is a negative x squared. And we have 2 of that, so it's going to be a minus 2x squared. Negative 1 times a negative 1 is going to be positive 1. I can combine like terms here. So my final answer for distance in terms of x is big radical. I'm going to write it in descending order, which is x to the 4th first. Negative 2x squared and a positive x squared will give me a minus x squared, and bring over my positive 1. And this right here, my dear, is the formula of the distance in terms of x. So I don't care what p is. P can be over here, p can be here, p can be here. And I can use the same formula as long as I know x. Okay. Alright, so part B. What is the distance if x is 0? Okay. So let's look at a drawing really quickly. Here's x. It's at 0. Well, the distance, okay, so when x is 0, I can go up, I can go down. So if I can't go up because there's nothing above, but if an x is 0, I can actually go down. So here's a point on the parabola when x is 0. As you can just count, the distance is 1 unit, okay? Because when x is 0, y is negative 1. And that is 1 unit from the origin. So let's use the formula to see, okay, if it's going to give us 1 unit. So we're going to take the radical when x is 0, 0 to the 4th. Take away 0 squared plus 1, which is the square root of 1. That means when when x is 0, the distance is 1, because square root of 1 is 1. So that confirms that the answer is correct, because we can totally just count it as well. Okay. Part C. What is d? What is the distance if x is positive 1? So we're going to find d of positive 1. Alright. So when x is 1, you only have one solution, as you can tell. Okay. When x is 1, I can just go to the right because I can't really go anywhere else. I can't go up because I'm not going to hit the parabola. I can't go down, so that's the only location. So the distance is also 1 unit from the origin. Okay, remember this. So let's test out algebraically to see if we're going to get 1. 1 to the 4th minus 1 squared plus 1. 1 to the 4th is 1. Minus 1 squared is also 1. So those two will cancel each other. So I have a square root of 1. Hence, the distance when x is 1, it's also 1 unit. Okay. So the distance when x is 0, it's also 1. The distance when x is 1, it's also 1. Okay. And it's not uncommon to have the equal distance at different locations. Alright, so next piece. What is the distance if x is square root of 2 over 2? Okay, so let's use our calculator here to decide what square root of 2 divided by 2 is. Square root of 2 divided by 2. It's about 0.71. Okay, so 0.71. So x is about 0.71. So what is the distance when x is about 0.71? Well, here's when x is 1. 0.71 is right here. Okay, so whatever the distance is, I can't go up, because if I go up, I'm not going to hit my parabola. So the only place I can go down is right about here. So I would like to know, if the point is here, when x is this, how long is that piece? Okay, well, that's a little more difficult to eyeball. So now we have to work it out using our algebra skill. So when x is rad 2 over 2, okay, we're going to substitute x with rad 2 over 2. So here we go. Rad 2 over 2 to the 4th power minus rad 2 over 2, and I need to square that and bring in my 1. Okay, so rad 2 over 2 to the 4th, that means I have 4 of those. So I'm just going to slowly write them out. Rad 2 over 2 times rad 2 over 2 times rad 2 over 2 times rad 2 over 2. That's what it means to have rad 2 over 2 to the 4th. Okay, now this one right here, I have 2 of that. I'm not going to write it out. You get the concept. So rad 2 times rad 2 is going to be simply 2. 2 squared is going to be 4. And 1, I'm just going to bring again that down. Let's try to simplify this piece right here. Okay, rad 2 times rad 2 is 2. Rad 2 times rad 2 is 2. 2 times 2 is 4. Okay, so I'm going to write this piece over here, just in case I'm out of space. So that's going to give me 4 in the numerator. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, I'm going to reduce that to 2 over 4 to 1/2. And again, bring down my 1. 4 over 16, let's reduce that again. That's going to be 1/4. And, well, looks like I have to unreduce this. Okay, so 1/2, let's change it back to 2/4 because I need to simplify. And 1, I'm going to need to convert that to 4 over 4. Okay, because I'm going to need to find the common denominator. So 1/4 take away 2/4 is going to be a negative 1/4. Okay, I'm going to add my 4 over 4. So this is going to give me positive rad 3. Rad 4 is going to be 2. Okay, so the distance, it's at rad 3 over 2, and if I have to use my calculator to find where that is, I'm just going to input that in. Rad 3 divided by 2 is about 0.87 units. Well, actually just unit apart, okay, from the origin. So when x is rad 2 over 2, or about 0.71 from the origin, okay, the distance from this x value, this point, it's about 0.87 units from the origin. Okay. Okay. Part E. Part E says, using a graphing calculator to graph the function d equals d of x, which we have found in the first problem, or the first step, part A. I just want x is greater than 0 or equal to 0. Round it to 2 decimal places, find the value or values of x at which d has a local minimum. Okay, so and I want you to give me this point or points on the graph of the parabola, which is x squared minus 1, which represent the closest point to the origin. Okay, so I'm going to ask you to sketch it out right here. So x is going to represent still x. Okay, y is going to represent the distance, okay, to the origin. Okay. So here we go. I'm going to plot in this function right here. Okay, so y equals, clear out whatever you had before. So big, huge radical. Input your x. And then use your caret to represent the 4th power. Then take away x squared. And we're going to bring down your 1. Close your radical. Your window's got to be from 0. And, okay, if x represents a point on here, let's try 10 first to see how far we can go. Okay, and then hit zoom and zoom fit. Okay, so zoom fit looks like it's giving me too large of a window. Okay, so window, giving me in almost 100. I'm not really interested in that much. Let's just go from -5 to +10 to see where that takes me. Okay, there you go. So if you look at my calculator, as you can tell, it looks like there is an absolute minimum here. So we're gonna make the Y window slightly smaller and an X window smaller as well. So I'm gonna go up to probably just 4 on the X. Y window, I want that to just be 5. Okay, hit graph again. I just want to see a better picture of what the minimum can be. And as we're zooming in, it's getting closer. Okay, so let's make the Y window like maybe from -2 to +2. Okay, -2 to +2, and then graph that out again. All right, so that looks a little bit better. You can just tell that it's starting up high and then it goes down a little bit. So I want to find this point right here. So second trace, go down to minimum, and we're gonna find a left bound. Here's my cursor. You have to go far enough. Okay, so here we go. There's my left bound. Hit enter. It's gonna ask you a second question. It's always gonna ask you 3 different questions. Okay, right bound. Hit enter, and I want to guess. There you go. Okay, so it says, hey, there is a minimum point. Okay, so let's sketch this out. There's a minimum point at, minimum at 0.71 comma 0.87. Okay, so let's sketch this out very quickly for me. It's gonna be, here's 1. Here is +1. It starts up a little bit on here and it goes down, and it looks like it goes back up this way. Okay. Okay. So that's my little sketch. So what does this point mean? Okay, this point means that this x value, when x is at 0.71, the shortest distance, okay, or the closest distance is 0.87 to the origin. Okay. So we're going to spell this out. The point on the graph of y equals x squared minus 1 that is closest to the origin is 0.71 comma 0.87. Okay. And I'm just going to end our lecture right here. Have a great day or great night, depending on when you're listening to this lecture. Oh, you know what? I forgot to tell you guys a joke, huh? All right, here's a joke. So in the hospital, the labor and delivery room, there are 3 dads, okay? Three men, okay? Anxiously waiting for their wives to give birth. So the first nurse came out and said, "Sir, congratulations. You know, you have twins." Oh, by the way, those are my kids crying. "Sir, congratulations, you have twins." And the dad was like, "Wow, that is so weird. You know, I just took a job with the Minnesota Twins, well, the baseball team." Then, you know, a few minutes later, a different nurse came out and said, "Sir, congratulations, you have triplets. You know, like, way to go." And so the dad's like, "Wow, that is really bizarre. I just took a job with AAA." And then here comes a guy screaming and running out of the hospital door. He said, "Oh my God, oh no, oh no, oh no, I just took a job with 7-Eleven." So he might have 7 kids or 11 kids. So anyway, that's my joke of the day. Have a good night.